All right, now we're going to be looking at real zeros of a polynomial function, okay? And you guys already know this, by the way. I'm just going to throw that out there. You guys did this in depth in Algebra 2, but we're going to go back over it and refresh you on some vocabulary, okay? So real zeros of a polynomial function, you get those when you break a polynomial down into its factors, and then you use the zero product property and solve each one of those factors. And I'm going to show you an example of that on the next slide. But really what this is we've got a lot of vocabulary here. What we want you guys to see, the gist of this whole thing, is that you're going to break things down into these factors that look like this. That's going to be x minus 3 or x plus 6 or something like that, okay? Then whenever we solve those, and I'll show you that on the next slide, you're going to end up with these values that we would say it would be a zero or a solution or a root. We could also call it an x-intercept, but we don't use that as often, but that's exactly what it is, and knowing it as an x-intercept helps you visually figure out what this is. So let's take a look at it on the next screen. Now, I just put a plain old quadratic equation up here, right? Just a plain old quadratic function. So with a quadratic, how are we going to solve this thing? Well, this is one of those deals where we're probably going to have to either use the quadratic formula or we're going to have to factor it, all right? So if I factor this thing down, I'm going to create my two sets of parentheses. And the reason we call it factoring is because we're actually creating factors. Factors are the things that you multiply together to get a product. The way that this quadratic is written is the product. That trinomial is the product. So to get our factors, we know that x's go in those first positions, x times x. Okay, so what we have to do is ask ourselves, what are the factors of negative 10 that would give me a sum of negative 3. Well, obviously, since this is negative 10, we're talking about having a negative times a positive, right? And then my sum comes up to be negative, so that means the negative factor from my negative 10 has to be larger. So it's going to be or more negative, if you will. So negative 5 and plus 2. All right, so let's double check. Negative 5 times 2 is in fact negative 10. Negative 5x and positive 2x make negative 3x, so I'm good to go. Okay, so this thing is now broken down into factors. Okay, so now what I'm going to do is take each one of these factors. I'm practicing using the vocabulary here, so pay attention to the words. And I'm going to use the zero product property. What we're doing is looking for where this thing crosses the x-axis. In other words, where the y value is equal to 0. So we want to find where these things cross this axis right here. So this is going to be 0 is equal to these factors multiplied together. And the zero product property says that we can set each one of those individual factors equal to 0 and solve. This should be really familiar to you. Then, when we add 5 to both sides, we end up with x equals 5. And when we subtract 2 from both sides, we end up with x equals negative 2. Okay, so here's the deal. This one and this one, by the way, are considered my factors. They're the ones that are in this x minus 5 or x plus 2 format. Now, when I solve those, that's what's going to give me solutions, roots. I could call them x-intercepts, or I can call them zeros of the function. Okay, so basically solution, root, x-intercept, and zero can all be used interchangeably, right? They pretty much mean the exact same thing. So they're showing them in slightly different ways here, but they all mean the same thing, okay? So that means this function, this parabola, is going to cross the x-axis at 5. So I can mark my x-intercept at 5. Notice I'm using that term again. And another x-intercept at negative 2. I can also call 5 and negative 2 zeros of this polynomial function. Or I can call 5 and negative 2 solutions or roots of the polynomial functions. All right, so we literally have 4 different words that mean the same thing here. But I want you to recognize how that relates to the factor, because that's just going to make your life a little bit easier. Okay, here we go. Next slide. All right, now to find real zeros of a polynomial function, I've got the steps written down here. If you would like to pause your video and jot down those steps, feel free. But we basically just went through the bulk of how we're going to break these things down into roots or zeros in the previous slide or on the previous slide. So in this one, the only thing that's different, you're going to notice that we have a cubic here. But what I hope you also notice is I have an x in every single term. So when we're trying to, our goal, by the way, our goal here is to start breaking down higher degree polynomial functions. We already know how to break down quadratics pretty well, and I know you guys covered this stuff in Algebra 2, but I'm not sure how much you remember because that's been a while ago. So now when we have, one of the first things you're going to look for when we have a higher degree polynomial function, the very first thing you're going to look for is to factor out any GCF. Okay, so greatest common factor. All right, you can see here we have a greatest common factor of x. That's going to leave me with an x squared plus x minus 2. If the remaining factor is a quadratic, which it is, find its zeros by factoring or by using the quadratic formula. So if you can factor relatively quickly and efficiently, I would say that is the better way to go. But if you struggle with that, you can always use the quadratic formula. Okay, so quadratic formula is never a wrong thing to do. It might not always be the most efficient thing to do, but it's never the wrong thing to do. I'm going to factor this down. So we're looking for the factors of -2 that give me a sum of +1. I know it's going to be 2 times 1. And my positive for my middle term means that my positive value is going to be that one who is further away from 0. Okay, so +2 and -1. So let's double check. Obviously, +2 times -1 is -2. This would be +2. This one would be -1. That's going to give me a +1 in there. So I'm all set. Now use the zero product property to find the zeros. That means I set each one of these things equal to 0, just like on the previous slide. And then I solve. This one's already solved. X equals 0. -2 on both sides gives me x is going to be equal to -2 plus 1 on both sides gives me x equals 1. Okay, so listing out all of my zeros, x would be -2, 0, or 1. And those are the zeros or the roots of the, or solutions of the cubic function. Okay, and obviously since I have a third degree function, I can expect that there are going to be 3 solutions, okay? And sometimes those can be, one can be a double root, but we'll get to that conversation in a different video. Okay, here's one that I'd like for you guys to pause your video real quick and have you give this a try. Okay, hopefully you had a minute to get those worked out, and I've just got the solution up here. This is what this broke down to for me, and therefore what the solutions or the roots or the x-intercepts are for this function. Okay, again, it's a cubic, and we have 3 roots. Third degree is going to